Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind, and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into a question that feels both vast and strangely personal, a question about reality itself, about life and death, and about whether the limits we've always accepted might not be limits at all. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a quiet kind of magic to see all the places we gather from, each of us resting in a different corner of the same unfolding universe. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey together. And if your mind begins to wander, that's perfectly fine, let it drift. We'll still be here. There is something quietly unusual about the time you were born into, not in the dramatic headline-making sense, but in a deeper, almost invisible way. A kind of slow shift beneath everything. The sort of change that doesn't announce itself loudly, but instead reshapes the world one layer at a time, like the tide moving in while you're not looking. For most of human history, life changed very slowly. If you'd been born 1,000 years ago, your life would have looked almost identical to the lives of your parents, and their parents, and generations stretching far back into memory. The tools were the same. The knowledge was the same. The sky above you, unchanged. And then, something began to accelerate. In the span of just a few centuries, a blink of an eye compared to the age of the Earth, humanity moved through a series of transformations so profound that they quietly redefined what it means to exist. First came the age of machines, when steam and steel began to replace muscle and effort. The world became louder, faster, more connected. Then came the age of electricity, when the night itself began to glow and distance started to feel a little less permanent. Then, not long after, the age of computation, when information could travel faster than any human ever could, and knowledge began to gather, stack, and multiply. And now, you find yourself in the age of intelligence, machines that can learn, systems that can recognize patterns, technologies that begin, in small and subtle ways, to resemble thought. But even this may not be the final step, because just beyond it, something else is emerging. A new way of understanding the world, not by observing it from the outside, but by stepping into its deepest layers. A way of computing that doesn't simply follow one path at a time, but gently explores many possibilities at once, like a mind dreaming through every option simultaneously. And if that sounds abstract, that's okay. You don't need to hold on to the details just yet. Just imagine this. Instead of solving a problem step by step, like walking down a single path in a forest, you are in some sense able to feel out all the paths at once. Every turn, every direction, every quiet possibility, not rushing, just unfolding. This shift from step-by-step thinking to possibility-based understanding may change more than just technology. It may change how we understand life, how we understand time, and perhaps how we understand death. Because for a long time, we've thought of ourselves as observers, standing at a distance, watching the universe unfold, measuring it, studying it, trying to make sense of it from the outside. But what happens when we're no longer just watching? What happens when we begin to shape the very systems we once only observed? There's a quiet idea, shared among some physicists, that captures this shift in a simple way, that humanity is slowly moving from being an audience to becoming a kind of composer, not controlling everything, not mastering the universe in any dramatic sense, but gently learning to influence the patterns, to understand the rhythm well enough to begin playing along, and that changes something fundamental. Because if reality is not as fixed as it seems, if it has layers, possibilities, hidden structures beneath the surface, then perhaps the boundaries we've always assumed between life and death, between one moment and the next, between what is real and what is possible, are not as rigid as they appear, not broken, just softer than we imagined. And tonight we're going to explore that softness, slowly, gently. We'll wander through the strange, quiet rules that seem to govern the smallest parts of reality, where certainty fades and possibility takes its place. We'll look at the idea that our universe might not be alone, but part of something larger, like a single ripple in a much wider ocean. And along the way, we'll return to a question that feels both ancient and deeply personal. What does it really mean to end? Or does anything truly end at all? For now, though, there's no need to answer anything. Just rest in the thought that you are here, at a moment in history where the boundaries of knowledge are shifting, where questions once considered impossible are being asked again, more quietly this time, but with greater clarity. You are living at the edge of something, not a sharp edge, but a soft one, the kind that feels less like a boundary and more like a doorway. And as we continue, we'll take a step closer, not rushing, not forcing, just allowing the ideas to unfold, one gentle layer at a time. Because the deeper we look, the more it seems that reality itself may not be a solid thing, but something far more fluid, something that waits patiently to be understood, and perhaps, in some small way, already understands you. There is a quiet assumption we carry through most of our lives that the world is solid, that things exist in definite places, that objects have clear positions, that if you leave something somewhere, it will still be there when you return. A cup sits on a table, a book rests on a shelf, a planet follows a predictable path around a star. Everything feels certain. And for most of our everyday experience, that assumption works beautifully. But as scientists began to look closer, deeper, into the smallest building blocks of reality, something unexpected began to happen. The certainty started to fade, not dramatically, not all at once, but gently, like a clear image slowly dissolving into mist. At the scale of atoms, and even smaller, the universe behaves very differently from what our intuition expects. Imagine trying to describe where something is, but every time you look more closely, its position becomes less defined. Imagine trying to measure how fast something is moving, but the more precisely you measure its motion, the less certain you become about where it is. This isn't a limitation of our tools. It's not because our instruments aren't good enough. It's because, at a fundamental level, reality itself does not seem to allow perfect certainty. This idea was captured in a principle discovered by Werner Heisenberg, something known as the uncertainty principle. But instead of thinking of it as a strict formula, imagine it more like a soft boundary, a gentle rule woven into the fabric of existence. It tells us that there are pairs of properties, like position and motion, that cannot both be known with perfect precision at the same time. The more tightly you hold one, the more the other slips away. Like trying to focus on a single drop of water in a flowing stream, you can see where it is, or how fast it's moving, but not both with perfect clarity. And this is where the world begins to feel different. Because if you can't say exactly where something is, or exactly how it's moving, then what is it, really? To begin to answer that, physicists turn to a new way of describing reality, something less rigid, more fluid. Instead of thinking of particles as tiny solid objects, like little marbles, they began to describe them as waves of possibility, not here or there, but spread out like ripples on a pond. A particle, before you observe it, is not sitting quietly in one place. It exists as a range of possible locations, a soft cloud of could be, and only when you interact with it, when you measure it, does it seem to settle into a definite position. It's as if reality, at its deepest level, is not fixed, but waiting. There's a famous idea in quantum physics that captures this strange behavior, often illustrated through a thought experiment. You may have heard of it, the idea proposed by Erwin Schrödinger, a simple box sealed and quiet, containing a system that, according to the rules of quantum physics, can exist in multiple states at once, not one or the other, but both, until someone opens the box. Now, it's important to say gently, this is not something we see in everyday life. Cats are not quietly existing in multiple states in your living room, but at the level of particles, this kind of overlapping possibility, called superposition, is very real, and it has been tested again and again in careful experiments. One of the most beautiful of these is something called the double slit experiment. Imagine shining light, or even individual particles, through two tiny openings. If reality behaved the way we expect, each particle would pass through one slit or the other, like a tiny pebble. But instead, something stranger happens. Even when particles are sent one at a time, they create a pattern on the screen beyond, a pattern that suggests they pass through both slits at once, interfering with themselves, like overlapping waves. And here's the part that feels almost dreamlike. If you try to observe which slit the particle goes through, the pattern changes. The act of observing seems to influence the outcome. Now, this doesn't mean that consciousness magically controls reality, but it does suggest something subtle and profound, that the way we interact with the world, the questions we ask of it, can shape what we see. Reality, at its smallest scales, is not just sitting there, fully formed, waiting to be discovered. It is, in some sense, participating in the act of being known. And this idea, as strange as it may feel, is not speculation. It forms the foundation of modern quantum physics, a framework that has been tested with extraordinary precision. It's the reason we have technologies like lasers, semiconductors, and even the beginnings of quantum computing, systems that don't just follow one path at a time, but explore many possibilities simultaneously before settling into an outcome. And if you let that idea settle for a moment, it begins to shift something quietly inside your understanding, because it suggests that beneath the solid world you experience every day, there is a deeper layer, a layer where certainty softens into probability, where things are not simply this or that, but a gentle blend of could be, and perhaps this is where we begin to approach something even more interesting. Because if reality itself is built on possibilities, if at its core it is not fixed, but fluid, then what does that mean for the larger questions? For time, which we experience as a steady flow, for existence, which we think of as beginning and ending, and for the idea of something continuing, even when we believe it has stopped. We're not answering those questions yet, we're just letting them exist, like distant shapes in the fog. Because the deeper we go, the more it seems that the universe is not a rigid machine, but something softer, something that unfolds, one possibility at a time, and as we continue we'll take another step, gently, into that unfolding. If you stay with that idea for a moment, that reality, at its smallest scale, is not fixed but fluid. Something subtle begins to unfold. The world you experience every day feels stable, solid, predictable. You wake up, you walk across the room, you reach for a glass of water, and everything behaves exactly as expected. But beneath that familiar surface, something far quieter is happening. A kind of gentle dance, not of objects moving from place to place, but of possibilities, constantly unfolding, overlapping, and resolving. Imagine for a moment that every event, every tiny interaction is not a single path being followed, but a soft cloud of potential paths, all existing together until one becomes real. This is one of the ways physicists have come to describe the quantum world, not as a rigid sequence of causes and effects, but as a landscape of possibilities, where outcomes are not determined with absolute certainty, only with likelihood. And this likelihood is not vague or philosophical. It can be described, calculated, predicted with astonishing accuracy. There is a mathematical object, often called a wave function, that encodes all the possible states a system can be in. Now, instead of thinking of it as a complicated equation, imagine it as a kind of map. A map that doesn't tell you exactly where something is, but shows you all the places it might be. With different levels of likelihood, some areas of the map are brighter, more probable, others are dimmer, less likely. And when you finally observe the system, it doesn't choose randomly. It follows those probabilities, gently settling into one of the possible outcomes, like a drop of rain falling somewhere within a cloud, not predetermined to land on a specific leaf, but guided by invisible patterns of likelihood. This way of understanding reality was developed by physicists like Erwin Schrödinger and Max Born, who realized that the strange behavior of particles could be described not by definite paths, but by evolving patterns of probability. And this introduces something quietly profound, because it suggests that the universe, at its deepest level, is not telling a single story, but holding many possible stories at once. Now, in your everyday life, this doesn't feel noticeable, because as systems grow larger, involving trillions upon trillions of particles, these probabilities tend to settle into stable patterns. The uncertainty averages out. The world becomes predictable again. A chair stays where it is. A clock ticks forward. A planet follows its orbit. But underneath that stability, the quiet dance continues. Every electron in your body, every photon of light, every atom, still participates in this gentle unfolding of possibilities. And there is another layer to this story, one that feels even more surprising, because these possibilities don't always stay isolated. Sometimes they become connected in a way that seems to ignore distance entirely. This phenomenon is known as quantum entanglement. It was studied deeply by physicists like Albert Einstein, who found it so strange that he once described it as spooky action at a distance. And it does feel a little like that. Imagine two particles, created together, sharing a single quantum state. Even if they move far apart, across vast distances, they remain connected, not through a signal travelling back and forth, but through something more subtle. Their properties are linked. If you measure one and find a particular outcome, the other instantly reflects a corresponding outcome, not because information travelled faster than light, but because, in a deep sense, they were never fully separate to begin with. It's as if they are two notes, played from the same chord, still resonating with each other, even when heard in different places. Now, it's important to be gentle with this idea. Entanglement does not allow communication faster than light. It doesn't let us send messages across the universe instantly, but it does reveal something about the structure of reality. That separation may not be as absolute as it appears. At the smallest scales, the universe behaves less like a collection of independent objects, and more like a deeply interconnected system, a quiet web where relationships matter as much as individual things. And as you let that idea settle, it begins to soften the way we think about existence itself. Because if everything is built from these connected patterns of probability, then what we experience as solid reality is, in some sense, a stable pattern emerging from something far more fluid, like a wave forming on the surface of the ocean. The wave feels real, visible, distinct, but it is not separate from the water beneath it. It is a pattern, sustained for a time, before gently dissolving, and this brings us slowly, gently, to a deeper question. If reality is made of patterns, of probabilities, of connections, then what does it mean for something to begin or to end? When you think of a moment, a thought, even a life, it feels like a clear sequence, a start, a middle, an end. But in a universe built on probabilities, those boundaries may not be as sharp as they seem, because at every moment there are always multiple possibilities quietly present, even if only one becomes visible. And this doesn't make reality less meaningful. If anything, it makes it richer, because it suggests that what you experience is one path, gently selected from a vast landscape of potential, not random, not chaotic, but shaped by the deep structure of the universe itself. And as we continue, we'll begin to explore how this idea connects to something even larger, something that touches time, existence, and the question that quietly brought us here, not with urgency, not with certainty, but with the same gentle curiosity that has guided us this far. If you follow that thread just a little further, this idea that reality is built from possibilities, something quietly extraordinary begins to emerge, because if at every moment there are many possible outcomes, gently waiting, and only one becomes visible, then a simple question begins to form. What happens to the others? Do they simply disappear, fading away like thoughts you almost remembered? Or do they remain, somehow, beyond what we can see? This question led some physicists to consider a possibility that feels both vast and strangely intimate, that our universe may not be the only one, not in the sense of distant galaxies or faraway stars, but in the sense of entirely separate realities unfolding alongside our own. This idea is often called the multiverse, and while it may sound like something drawn from imagination, it emerges naturally from several serious attempts to understand how the universe works. One of these comes from the strange behaviour we've already explored. If a system can exist in multiple possible states, and if observation reveals only one, then one interpretation, proposed by physicists like Hugh Everett, suggests something rather elegant, that all possibilities are real, not just potential, but actual. In this view, when a quantum event occurs, the universe does not choose a single outcome and discard the rest. Instead, it gently branches. Each possibility unfolds in its own path, its own version of reality, its own quiet continuation. Now, it's important to approach this idea with care. These other branches are not places we can visit. They are not hidden behind a door or waiting somewhere in space. They are, in a sense, separate unfoldings of the same underlying reality, like different melodies emerging from the same instrument, but never crossing into each other. And yet, the idea carries a certain softness, because it suggests that reality is not a single, rigid line, but something more like a tree with countless branches extending outward in every direction. At every moment, new branches forming as possibilities gently become real. And somewhere within that vast structure, there may be versions of events that unfolded differently, not dramatically, not in ways that feel like fantasy, but in small, subtle variations, a different choice, a different outcome, a different path. Now, this is just one way of thinking about the multiverse. There are others, equally fascinating, equally grounded in physics. Some arise from our understanding of the early universe, the moment when space itself expanded rapidly, stretching tiny fluctuations into the vast structure we see today. In some models of this expansion, the process doesn't happen just once, it happens repeatedly, in different regions, creating what are sometimes described as bubble universes, each one forming, expanding, evolving with its own conditions, its own laws, perhaps slightly different from ours, its own story. You might imagine it like a vast quiet ocean where bubbles form, grow, and drift apart, each bubble a universe, each one self-contained, never colliding, never merging, just existing, side by side, in a space far larger than we can observe. And then there is another idea, emerging from attempts to unify the fundamental forces of nature, something known as string theory, instead of treating particles as tiny points. String theory suggests that the most fundamental elements of reality are incredibly small, vibrating strands, not visible, not tangible, but oscillating, like the strings of a musical instrument, and just as different vibrations produce different notes, these tiny vibrations give rise to different particles, different properties, different forms of matter. In this picture, the universe is not built from solid pieces, but from patterns of vibration, a kind of cosmic symphony, playing at scales far beyond direct perception. And within this framework, something unexpected appears, a vast landscape of possible configurations, different ways these vibrations can exist, different ways the dimensions of space might be arranged, each configuration potentially corresponding to a different universe, not hypothetical in the sense of imagination, but allowed by the mathematics of the theory. Now, it's important to remain gentle with this idea. String theory is still being explored. It is not yet confirmed in the way other theories are, but it offers a way of thinking about reality, where the universe we experience is just one of many possible expressions of a deeper underlying structure. And when you step back and take all of these ideas together, the quiet branching of possibilities, the formation of separate cosmic regions, the vast landscape of underlying structures, a picture begins to form, not sharp, not fully defined, but suggestive, a picture of reality, not as a single, isolated system, but as part of something larger, something layered, something expansive, beyond what we can directly observe. And within that picture, our universe, with its stars, its galaxies, its quiet moments, becomes one expression, among many, not less meaningful, but perhaps more connected to a wider structure. Now, this doesn't mean that everything is possible in a careless sense. The laws of physics still guide what can happen. Patterns still follow structure, but it does suggest that the space of possibilities is far richer than what we see in a single unfolding. And as you let that idea rest, gently, without forcing it, it begins to soften something in the way we think about existence. Because if reality is not limited to a single path, if it includes many possible unfoldings, then the boundaries we draw between one outcome and another may not be as absolute as they appear, not broken, just wider. And as we continue, we'll begin to explore how this connects to something closer to home, something that touches not just the universe, but the body, the mind, and the quiet question of how long anything truly lasts. As we sit with that idea, that reality may not be a single unfolding, but part of something wider, something layered. It becomes natural to ask another quiet question. If there are deeper structures beneath what we see, are we really seeing most of the universe at all, or just a small, familiar surface, resting above something much larger? Because when scientists began to observe the cosmos more carefully, not just through telescopes, but through the motion of galaxies and the behavior of light, they discovered something unexpected, something that didn't quite fit. Galaxies were spinning, but not in the way they should. If you imagine a spinning disk, like a record turning on a player, you would expect the outer edges to move more slowly than the inner parts. That's how systems behave when only visible matter is involved. But galaxies didn't follow that pattern. The outer stars, or far from the centre, were moving much faster than expected, as if something unseen, something massive, was holding them in place. At first, this was puzzling, but as more observations came in, a pattern began to emerge. There seemed to be more mass than we could see. Not a little more, a lot more. And this invisible presence was given a simple name: dark matter. Not because it is black or shadowy in the way we might imagine, but because it does not interact with light. It doesn't glow. It doesn't reflect. It doesn't absorb light in any way we can easily detect. And yet, it has gravity. It influences motion. It shapes the structure of galaxies, and even the large-scale structure of the universe. You can think of it like an invisible framework, a kind of quiet scaffolding, holding everything together. If the visible universe, stars, planets, gas, is like the paint on a canvas, then dark matter is the hidden structure beneath it, the frame, the texture, the unseen support. And when scientists added up all the matter we can observe, they found something surprising. Everything we see, every star, every galaxy, every cloud of gas, accounts for only a small fraction of the total, roughly speaking about 5%. The rest is something else. And that brings us to another layer, even more subtle, something that doesn't just hold things together, but seems to be gently pushing the universe apart. When astronomers observe distant galaxies, they notice that the universe is expanding. That part was already known, but what they discovered was more surprising. The expansion is not slowing down, it's accelerating. As if, on the largest scales, something is quietly stretching space itself. This mysterious influence was given another simple name: dark energy. Again, not something we can see directly, not something we can touch or measure in a familiar way, but something we can infer from the way the universe behaves. If dark matter is like an invisible framework, dark energy is more like a gentle pressure, a quiet tendency for space to expand, not explosively, not violently, but steadily, persistently, over immense stretches of time. And when you place these two ideas side by side, dark matter shaping structure, dark energy guiding expansion, a picture begins to form, one where most of the universe is not made of the things we're familiar with, but of something deeper, something still not fully understood. And this connects, in a quiet way, to the ideas we explored earlier. Because if reality includes layers we cannot directly observe, if most of what exists is hidden beneath the surface, then the world we experience is only part of a much larger system. Now, there is an interesting possibility that emerges from some versions of string theory, the idea that these unseen components might not be entirely separate from the visible world, but could be connected to dimensions beyond the ones we experience, not dimensions in the sense of distant places, but additional directions woven into the structure of space itself, too small, too subtle to notice directly, like tiny folds hidden within the fabric of reality. And while this idea remains speculative, it offers a gentle way of imagining how something could be present, influential, and yet invisible, like a melody playing at a frequency just beyond hearing, still shaping the harmony, even if you don't consciously perceive it. And this brings us back, in a soft and natural way, to the idea of structure. Because when scientists map the universe on its larger scales, they don't see a random scattering of galaxies. They see something more organized, a vast network, often called the cosmic web, filaments of galaxies stretching across space, connected at dense nodes, with enormous empty regions in between. It looks, in a way, like a three-dimensional web or a network of threads woven across the cosmos. And dark matter appears to form the backbone of this structure, guiding where galaxies form, where they cluster, and where vast empty regions remain. It is quiet, invisible, but essential, and when you step back and let all of this settle, a certain feeling begins to emerge, not of confusion, but of depth, the sense that reality is layered, that what we see is just one level, resting above something more expansive, something still being uncovered, slowly, carefully, by observation, by theory, by patient curiosity. And this doesn't make the world less real. If anything, it makes it more meaningful, because it suggests that every moment, every object, every experience is part of a much larger structure, one that extends beyond immediate perception, but still shapes everything we know. And as we continue, we'll begin to explore how this deeper structure connects not just to the universe, but to life itself, to the processes within the body, to the quiet unfolding of time, and to the question that has been gently waiting in the background: what it means for something to continue, even when it seems to disappear. As we move gently through these layers of understanding, from the visible world into the unseen structures beneath it, another idea begins to take shape, not about what exists, but about how it is arranged. Because for a long time we've imagined space as something simple, three directions, forward and backward, left and right, up and down, a kind of invisible stage where everything else takes place, and time flowing steadily like a quiet river. But as physicists tried to bring together all the pieces we've explored, quantum behavior, gravity, the structure of the universe, they began to suspect that this picture might be incomplete, not wrong, just missing something. One of the boldest attempts to complete that picture is what we mentioned earlier, says string theory. And to understand it, we don't need equations. We can begin with something much softer. Imagine for a moment that everything you see, every particle, like every atom or every star, is not a tiny solid point, but a very small, vibrating strand, so small that it cannot be seen directly, even with the most powerful instruments, but always moving, always oscillating in delicate patterns. Now, if you've ever seen the string of a musical instrument vibrate, you know that different patterns of vibration produce different notes. A low, steady tone, a higher, more delicate sound, all from the same string, simply vibrating in different ways. String theory suggests something similar, that what we call particles, electrons, photons, quarks, are not fundamentally different objects, but different vibrations of the same underlying structure, like different notes played on a single instrument. And if that idea feels calm, almost poetic, that's because it is. It replaces the image of the universe as a collection of separate pieces with something more unified, a kind of quiet harmony where everything emerges from patterns of motion. Now, as scientists explored this idea more deeply, they encountered something unexpected. The mathematics only seemed to work if space had more than the 3 dimensions we experience, not just length, width, and height, but additional directions hidden from everyday perception. These extra dimensions are not like distant places you could travel to. They are thought to be incredibly small, curled up, folded into the structure of space itself. A helpful way to imagine this is to think of a very thin thread. From a distance, it looks like a simple line, one-dimensional. You can move along it, forward or backward. But if you zoom in closely, you notice that the thread has a tiny circular thickness, a second direction, wrapped tightly around the first, too small to notice from far away, but still there. In a similar way, the extra dimensions in string theory are thought to be wrapped, compact, hidden at scales far smaller than anything we can directly observe, and yet they may influence how the strings vibrate, and therefore how particles behave, which means, in a quiet and indirect way, they may shape the entire structure of reality. Now, it's important to say gently, this is still a developing idea. String theory is not yet confirmed in the same way as some other parts of physics, but it offers a powerful framework, a way of imagining the universe, where everything is connected through deeper geometry. And when you sit with that idea, the universe begins to feel different, not just a vast empty space, but something more textured, more intricate, more layered, like a fabric, woven with patterns we can only partly see. And this brings us to another subtle shift in perspective, because if reality is built from these underlying structures, if particles are vibrations, if dimensions are layered and hidden, then space itself may not be as simple as it appears. It may have a kind of shape, a geometry that guides how things move. This idea was explored deeply by Albert Einstein, who showed that gravity is not just a force pulling objects together, but a curvature, a bending of space and time. Instead of imagining gravity as something that reaches out and pulls, you can think of it as the shape of the stage itself. Mass, like a star or a planet, changes the geometry around it, and other objects simply follow the curves, like a marble rolling across a gently curved surface, not being pulled directly, but guided by the shape beneath it. And this idea has been tested again and again, from the motion of planets, to the bending of light, to the precise timing of satellites orbiting Earth. It works beautifully, and when you place this alongside the ideas from quantum physics, something intriguing begins to emerge. On one hand, reality is made of probabilities, possibilities, gentle clouds of potential. On the other, it is shaped by geometry, curvature, structure, and bringing these two together has been one of the deepest challenges in modern science, a quiet puzzle, still being explored because it suggests that at the deepest level, reality may be both fluid and structured, uncertain and guided, like a piece of music that allows for variation but still follows an underlying harmony, and as you let that image settle, it begins to connect in a soft way to something we touched on earlier, the idea that the universe might not be a single configuration, but one of many possible arrangements. Because if the geometry of space can vary, if the way dimensions are folded can change, if the patterns of vibration can differ, then different universes could arise from different underlying structures, not randomly, but as different expressions of the same deeper system, like different song played on the same instrument, each with its own melody, its own rhythm, but all emerging from the same set of strings. And this brings us gently to a point where physics begins to touch something more personal, because these ideas, as vast as they are, don't only describe distant galaxies or abstract systems, they describe the same underlying reality that forms your body, your thoughts, your existence in this moment. And as we continue, we'll begin to bring these ideas closer, from the structure of the universe, to the processes within life itself, to the quiet unfolding of time within the body, and to the question that has been waiting just beneath the surface, not asked loudly, but present nonetheless. What does it mean for something to change? And what does it mean for something to truly end? If you take everything we've explored so far, the quiet uncertainty beneath matter, the hidden geometry of space, the idea that the universe may be built from patterns rather than solid things, a different kind of image begins to form, not of particles, not of objects, but of something softer, something more like music. Imagine for a moment that reality is not made of tiny pieces, but of vibrations, not random, not chaotic, but structured, rhythmic, quietly precise, like the gentle movement of a string. If you've ever listened closely to a piano or a violin, you might have noticed something subtle. The note you hear is not just a single sound, it's a pattern, a vibration. The string moves back and forth, creating waves in the air, and your ears translate those waves into something meaningful, a tone, a feeling, a moment. Now imagine that instead of sound, these vibrations are happening at a scale so small, so delicate, that they form the very foundation of everything you see. That what we call particles are not tiny objects, but tiny notes, different vibrations, producing different properties. One pattern becomes something we call an electron. Another becomes a particle of light. Another, something heavier, something that helps build the structure of atoms, not separate things, but different expressions of the same underlying motion. This is the quiet idea at the heart of string theory. That reality at its deepest level is not made of solid building blocks, but of vibrating strands, and each vibration carries its own identity, its own role, its own place in the greater harmony. Now, you don't need to imagine these strings literally, like threads floating in space. It's enough to feel the idea that everything is pattern, everything is motion, everything is part of a larger composition. And when you begin to see the universe this way, something shifts, because instead of a world made of separate objects, you begin to sense a world made of relationships, interactions, resonances, like a piece of music where no single note exists in isolation, each one shaped by what comes before it and what follows. Now there is another quiet detail hidden in this picture, because not all vibrations are the same. Some are simple, steady, easy to recognize. Others are more complex, layered, subtle, and some may be so delicate or so high, or so faint that we don't perceive them at all, like sounds beyond the range of hearing, still present, still real, but outside our direct awareness. And this is where the idea begins to expand, because if reality is made of vibrations, and if there are patterns we can perceive and patterns we cannot, then what we experience as the universe may be only part of a much larger symphony, a small range of notes within a far wider spectrum. You can imagine it like sitting in a quiet room, listening to a piece of music. You hear the melody, you follow the rhythm. But beyond what you hear, there may be deeper tones, higher frequencies, subtle harmonies that your ears simply cannot detect, and yet they are still part of the composition, still shaping the whole, still present, just beyond perception. In a similar way, the universe we experience may be only the audible portion of something much larger. Now, this doesn't make your experience less real. The music you hear is still music. The notes you feel are still meaningful. But it suggests that there may be layers, additional patterns, quietly woven into reality that we are only beginning to understand. And this connects, in a gentle way, to something we touched on earlier. The idea that much of the universe is hidden, not in a mysterious or mystical sense, but simply not directly observable. If there are vibrations we cannot detect, if there are patterns beyond our sensory range, then it becomes easier to imagine how something could exist, influence the universe, and yet remain unseen, not absent, just inaudible. And this brings a kind of calm perspective, because it reminds us that our view of reality is not the whole picture. It is a window, a beautifully detailed, carefully evolved window, but still a limited one. And beyond that window, there may be more structure, more variation, more quiet complexity. Now, as you sit with this idea, there's no need to fully grasp it. You don't need to visualize every layer or understand every implication. It's enough to let the feeling settle, that the universe is not silent, that beneath everything you see, there is a kind of quiet resonance, a constant unfolding of patterns, and that you, in this moment, are part of that unfolding, not separate from it, not observing from the outside, but participating, gently, in the same quiet symphony. Your body, your thoughts, your awareness, all emerging from the same underlying patterns, the same subtle vibrations that shape everything else. And as we continue, we'll begin to explore what lies just beyond the notes we can hear, the hidden layers, the unseen structures, the parts of reality that don't announce themselves, but are always there, quietly, shaping the music. If you sit quietly with that image of reality as a kind of music, a symphony of vibrations, some heard, some unheard, a gentle question begins to emerge. What if most of the music is happening outside the range of what we can perceive, not absent, just beyond our senses? Because when scientists began to look more closely at the universe, not just at what shines, but at how things move, they discovered something quietly astonishing. The universe does not behave as if it is made only of the things we can see. In fact, most of it appears to be something else entirely. Let's begin with something simple. Imagine watching a carousel, slowly spinning in the evening light. The horses near the centre move gently, while those at the outer edge move faster, covering more distance as they circle around. This feels natural, intuitive. Now imagine that the outer horses suddenly begin moving just as slowly as the inner ones, or even faster, in a way that doesn't match what you expect. You would pause, something would feel off. This is very similar to what astronomers observed when they studied galaxies. Stars near the edges of galaxies, far from the centre, were moving much faster than expected. According to everything we understand about gravity, they should have drifted away, gently escaping into space. But they didn't. They stayed, as if something invisible, something massive, was holding them in place. At first, this was confusing, but observation after observation across many galaxies revealed the same pattern. There had to be more mass, more gravitational influence than what we could see. And so, a quiet idea was given a name: dark matter, not because it is dark in the way we imagine shadows, but because it does not interact with light. It doesn't glow, it doesn't reflect, it doesn't reveal itself directly. And yet, its presence is unmistakable. It shapes the motion of galaxies. It influences how clusters of galaxies form. It acts like an invisible framework, quietly holding the universe together. You can imagine it like the unseen scaffolding behind a building. You don't notice it when everything is complete. But without it, the structure wouldn't hold. And when scientists tried to measure how much of the universe is made of this invisible substance, they found something even more surprising. Everything we can see, stars, planets, gas, dust, accounts for only a small portion, a thin layer of a much larger whole. Roughly speaking, about 5 parts out of 100. The rest is something we do not directly perceive. And if that feels a little unsettling, there is another layer still, because not only is most of the universe invisible, it is also expanding. Now, expansion itself is not surprising. The universe has been growing ever since its earliest moments, but what surprised scientists was the way this expansion behaves. Instead of slowing down, as gravity pulls things together, it is accelerating, very gently, very quietly, but persistently, as if space itself is being stretched, not pulled apart violently, but softly, continuously, over vast stretches of time. This effect is attributed to something we call dark energy, and just like dark matter, it is not something we can see directly. We don't observe it the way we observe stars or light. We infer it from the way distant galaxies move, from the way space itself seems to grow. If dark matter acts like an invisible framework, then dark energy is more like a subtle pressure, a quiet tendency for space to expand. You might imagine it like the slow rising of dough, not dramatic, not sudden, but steady, inevitable, shaping the structure from within. And when you place these two ideas together, dark matter, holding things together, dark energy, gently pushing things apart, a new picture of the universe begins to form, one that feels less like a simple collection of objects, and more like a dynamic system, balanced between forces we can see and forces we cannot. Now, there is something deeply calming about this idea, because it reminds us that what we perceive is only part of the whole. Our senses, our instruments, our understanding are like a small window, opening onto a vast landscape, and beyond that window there is more, not chaotic, not unknowable, but simply not yet fully revealed. And this connects beautifully to the idea we explored before. That reality may contain layers, different notes in the symphony, some within our range, some beyond it. In fact, some physicists have wondered whether these unseen components might be connected to deeper structures of reality, possibly even to dimensions beyond the ones we experience directly, not as distant places, but as subtle directions, folded into the fabric of space, too small, too quiet to detect directly, but still influencing everything, like a harmony you can't quite hear, but can somehow feel. Now, whether this connection is ultimately true is still an open question. Science moves slowly, carefully, testing each idea, but the possibility itself is gentle, because it invites us to see the universe not as incomplete, but as partially revealed. And when we map the universe on its largest scales, we begin to see patterns that reflect this deeper structure. Galaxies are not scattered randomly. They form long filaments, stretching across space, intersecting at dense clusters, leaving vast quiet voids in between. This structure is often called the cosmic web, and dark matter appears to form its backbone, guiding where galaxies gather, where they drift apart, where structure emerges, and where emptiness remains. It is a quiet architecture, invisible but essential. And when you step back and let all of this settle, a feeling begins to emerge, not of mystery, but of depth, the sense that reality is layered, that what we see is only the surface of something far more intricate. And this doesn't make the universe feel distant. If anything, it makes it feel closer, because it suggests that every moment, every object, every breath is part of a much larger unfolding, one that extends beyond what we can perceive, but still shapes everything we are. And as we continue, we'll move even deeper into that quiet background, into the space that is never truly empty, into the subtle fluctuations, the tiny flickers of possibility that may give rise to entire universes appearing and fading in ways that feel almost like a dream. As we move gently beyond what we can see, beyond the visible stars and galaxies, beyond even the invisible structures that shape them, we arrive at something even quieter, something that feels almost empty, but is not. Because one of the most surprising discoveries in modern physics is this: what we call empty space is not truly empty at all. If you imagine space as a vast silent void, completely still, completely calm, the reality is more subtle, more alive, more active, in a very quiet way. At the smallest scales, space is constantly shifting, tiny fluctuations, gentle changes, appearing and disappearing, so quickly that they never become part of the stable world we experience. You can think of it like the surface of a very still lake. From a distance, it looks perfectly smooth, but if you look closely, you might see the faintest ripples, forming and fading, too small and too brief to travel far. In a similar way, the fabric of space itself seems to have these tiny, restless movements. Physicists sometimes describe them as quantum fluctuations, not dramatic events, not explosions or sudden changes, but small, fleeting variations in energy, occurring everywhere, all the time. Now, it's important to keep this idea soft. We're not talking about something visible or tangible. These fluctuations don't form objects you can touch or see. They're more like momentary possibilities, briefly appearing, then dissolving. And yet, they are real enough to have measurable effects. They influence how particles behave. They subtly shape the structure of the vacuum, the background of everything. And this leads to a quiet but profound possibility. Because if space can fluctuate, even slightly, then under the right conditions, those tiny fluctuations could grow. Not usually, not in the calm, stable universe we inhabit now, but perhaps, in certain rare circumstances, a way small fluctuation could expand, stretch, stabilize, becoming something larger, something lasting. there is an idea, explored by physicists like Stephen Hawking, that touches on this possibility, the suggestion that our universe itself may have begun as one of these fluctuations, a tiny, almost imperceptible variation, that, instead of fading away, expanded, rapidly, quietly, becoming the vast cosmos we now observe, not created from nothing in a dramatic sense, but emerging from the subtle activity of the vacuum itself. Now, this doesn't mean that universes are constantly appearing around us in any noticeable way. These processes, if they occur, would unfold at scales and energies far beyond everyday experience. But the idea itself is gentle, because it suggests that the universe is not a fixed, singular event, but part of an ongoing process, a background, where possibilities can give rise to structure, where something can emerge from something quieter, more subtle, and this brings us back in a soft and natural way to the multiverse. Because if one fluctuation could become a universe, then perhaps others could as well, not here, not nearby, not accessible, but elsewhere, in ways we cannot directly observe, each one beginning in its own way, expanding, evolving, carrying its own patterns, its own history. You might imagine it like a vast quiet ocean, where small ripples occasionally grow into waves, each wave forming, rising, then continuing on its own path, never colliding, never merging, just existing, alongside others, in a space far larger than any single wave, and within that picture, our universe becomes one such wave, not the only one, not necessarily the first, but one expression of a deeper, ongoing process. Now, there is something calming about this idea, because it shifts the way we think about beginnings. Instead of a single sharp moment, it suggests something more gradual, more continuous, more natural, a process rather than an event. And this connects gently to something even closer to our own experience. Because when we think about beginnings and endings in our own lives, we often imagine them as clear boundaries, a start, a finish, a moment when something appears, and a moment when it disappears. But in a universe where fluctuations give rise to structure, where patterns emerge and dissolve, those boundaries may be softer than they seem, not absolute, but part of a larger flow. Now there is another subtle idea hidden here, because these fluctuations, these tiny variations in energy, are not random in a careless sense. They follow patterns. They obey the underlying structure of physics. They are guided by the same quiet rules that shape everything else. And this means that even at the deepest levels, there is a kind of order, not rigid, not deterministic in the way we once imagined, but structured, consistent. Like the background rhythm of a piece of music, steady, even when the melody changes. And as you sit with that, just for a moment, the universe begins to feel less like a static place, and more like a process, a continuous unfolding where new patterns can emerge and old ones can gently fade. And this brings us softly to the next step in our journey. Because if reality is built from possibilities, if it allows multiple paths, if it can give rise to entire universes from subtle fluctuations, then a natural question begins to form. What happens when we begin to understand these patterns, not just observe them, but work with them? Because humans have always built tools to extend their abilities, to see further, to understand more deeply. And now, we're beginning to build something new, machines that don't just calculate step by step, but begin to reflect the very nature of reality itself, machines that can explore possibilities in a parallel, much like the quantum world we've been describing. And as we move forward, we'll begin to explore these machines not as cold mechanical devices, but as quiet extensions of the same patterns that shape the universe, a new way of thinking emerging, gently, from everything we've just seen. As we gently arrive here, after wandering through possibilities, unseen layers, and the quiet emergence of entire universes, a new idea begins to take shape. Not about what reality is, but about how we might begin to understand it. Because for a long time, the tools we've built to think about the world have followed a very simple pattern. A pattern built on certainty, on clear choices, on something like a yes or a no, a 1 or a 0. This is the foundation of classical computing. Every calculation, every image, every message you've ever sent or received, all of it, built from tiny decisions, on or off, true or false. And when these simple choices are arranged in vast numbers, they become incredibly powerful. They allow us to simulate weather patterns, to map the human genome, to send signals across the planet in an instant. But beneath that power, there is still a limitation, because each step, each calculation, follows a path, one after another, like walking through a maze, choosing one turn at a time. Now, imagine something different. Imagine that instead of walking a single path, you could explore many paths at once, not by moving faster, but by holding multiple possibilities simultaneously, not choosing immediately, but allowing options to exist together for a time. This is the gentle idea behind quantum computing, and it grows directly out of everything we've already explored. Because if reality itself allows for multiple possibilities to exist together, then perhaps our tools can begin to reflect that. In a classical computer, the smallest unit of information is called a bit. It can be either 0 or 1. But in a quantum system, the basic unit is something softer. It can be in a state that represents 0 and 1 at the same time, not fully one, not fully the other, but a blend, a range, a possibility. You don't need to imagine this as something abstract. Think of it like a dimmer switch, instead of a simple on-off light. A classical bit is like a switch that is either fully off or fully on. A quantum bit, sometimes called a qubit, is more like a smooth transition, a gentle range between those states. Now, this doesn't just add a little flexibility, it changes the nature of computation itself. Because when multiple possibilities can exist together, a system can explore many outcomes at once, not by trying each one separately, but by holding them in parallel, allowing them to evolve together. A helpful way to imagine this is to think of a maze. A classical computer approaches the maze by trying one path, then another, carefully, step by step. But a quantum system is more like a gentle mist, spreading through the maze, touching many paths simultaneously, not rushing, not forcing, but exploring, quietly, all at once. And when the process completes, the system settles into an outcome. One path becomes visible, guided by the structure of all the possibilities it explored. Now, this may sound almost magical, but it is grounded in the same principles we've already seen: superposition, the ability to hold multiple possibilities, and entanglement, the deep connection between parts of a system. Together, these allow quantum systems to process information in a fundamentally different way. Not faster in a simple sense, but broader, more parallel, more aligned with the way reality itself seems to behave. And this has profound implications, because there are problems in the world that are incredibly difficult for classical computers. problems where the number of possibilities becomes so large that exploring them one by one would take longer than the age of the universe. But a quantum system can approach these problems differently, not by brute force, but by gently navigating the landscape of possibilities, finding patterns, relationships, solutions in ways that are not easily accessible otherwise. And this opens the door to something quietly powerful, because it means we may begin to understand systems that have always been too complex, the behavior of molecules as they fold into intricate shapes, the interactions within living cells, the subtle dynamics of climate, the emergence of structure from complexity. All of these are systems where many possibilities interact at once, and now we are beginning to build tools that can reflect that. Now, it's important to stay grounded. Quantum computers are still developing. They are delicate, sensitive, not yet ready to replace classical systems in everyday use, but they are growing, slowly, steadily, like a new kind of language just beginning to form. And what makes this especially interesting is not just what they can do, but what they represent, because they are not simply machines. They are, in a sense, extensions of the principles we've been exploring. They take the quiet rules of the quantum world and bring them into our ability to compute, to simulate, to understand. And this creates a kind of bridge between the deep structure of reality and the tools we use to explore it. Now, if you let that idea settle for a moment, something begins to shift. Because for the first time, we're not just observing the strange behavior of the universe, we're beginning to work with it, to build systems that reflect it, to gently align our tools with the deeper patterns of existence. And this changes something fundamental, because when your tools change, your understanding changes. And when your understanding changes, the questions you can ask begin to expand. And as we continue, we'll begin to explore what those new questions might be. Not abstract ones, but deeply human ones. Questions about life, about health, about time, and about whether the limits we've always accepted are as fixed as they seem. As we sit with this new idea, that computation no longer needs to follow a single path, that it can gently explore many possibilities at once, another realization begins to emerge, a quiet one, almost easy to miss, because in a sense, this way of computing is not entirely new. It has been happening all along, not in our machines, but in nature itself. If you look closely at the world around you, not at the surface, but at the processes beneath, you begin to notice something subtle. Nature does not solve problems step by step, in a rigid, linear way. It explores, it adapts, it allows many possibilities to unfold, and then gently settles into what works. Think of a simple leaf resting in the sunlight. At first, it seems still, passive, but inside, something intricate is happening. Light arrives in tiny packets of energy. These packets don't follow a single path through the leaf. They move in a way that seems almost exploratory, sampling multiple routes, interacting with molecules, finding the most efficient way to transfer energy, all without intention, all without thought, just following the quiet rules of physics. And yet, the result is remarkably efficient, more efficient than many systems we've built ourselves. Now consider something even closer, your own body. Every moment, inside you, countless processes are unfolding, proteins folding into precise shapes, molecules interacting, signals travelling, decisions being made, not consciously, but through networks of interactions. Your body does not calculate each possibility. One by one, It allows patterns to emerge. It lets interactions play out in parallel. And from that complexity, something stable arises, something that feels continuous, alive. In a way, your body is not a machine in the traditional sense. It is a system that explores possibilities constantly, quietly, and maintains balance, not by rigid control, but by gentle adaptation. And this is where something interesting begins to happen. Because as we develop quantum computers, we're not just building faster machines, we're beginning to build systems that behave more like nature, systems that do not force a single path, but allow multiple possibilities to coexist, interact, and resolve. It's as if, after centuries of trying to simplify the world into clear, step-by-step logic, we're beginning to move in the opposite direction, towards something more fluid, more natural, more aligned with the underlying patterns of reality. Now, this doesn't mean that nature is thinking in the way we do. There is no intention, no awareness in these processes. But there is a kind of quiet intelligence, not conscious, but structured. A tendency toward patterns that work, toward configurations that persist, toward solutions that emerge without being explicitly designed. And this is something we're only beginning to understand, because when you look at systems like ecosystems, or the human brain, or even the formation of galaxies, you see the same pattern, complexity, giving rise to order, not through rigid control, but through interaction, through feedback, through the gentle balancing of possibilities. And this is what makes quantum computing feel so different, because it doesn't just increase our ability to calculate, it shifts the way we approach problems. Instead of forcing a system to follow a narrow path, we allow it to explore a wider landscape, to consider many configurations simultaneously, and then, to settle into something that fits. Now, imagine what this means when applied to the challenges we face. There are problems in the world that are not simple, not linear, not easily broken down into clear steps. The behavior of complex molecules, the folding of proteins into precise shapes, the interactions within a living cell. These are not problems with a single path to follow. They are landscapes filled with possibilities. And classical computers, for all their power, often struggle with this kind of complexity, because they must explore each possibility one at a time. But a quantum system can move through that landscape differently, not exhaustively, but holistically, sensing patterns, navigating possibilities, finding structure within complexity. And this brings us back, in a quiet way, to the idea of alignment, because what we are building are not just tools to control the world, but tools that begin to resonate with the way the world already works. And that changes something subtle but important, because for a long time, human technology has been about imposing order, taking a complex system and simplifying it, reducing it, controlling it. But now, we are beginning to do something different. We are beginning to listen, to observe how nature solves problems, and to build systems that follow similar principles, not identical, but inspired. And this creates a kind of harmony, a sense that our tools are no longer separate from the universe, but extensions of it, emerging from the same patterns, the same principles, the same quiet rules. And when you let that idea settle, it begins to shift the way you see progress, because it's no longer just about becoming more powerful. It's about becoming more aligned, more attuned to the deeper structure of reality. Now, this doesn't mean everything becomes simple, or that all problems will suddenly be solved, but it does open a door, a gentle possibility, that we may begin to understand systems, that once felt too complex, too intricate, too vast. And as we step through that door, slowly, carefully, we begin to approach something deeply human. Because the same patterns we see in nature, the same complexity, the same quiet balance, exist within us, within our bodies, within our lives. And as we continue, we'll begin to explore how this new way of understanding touches something very close. The processes that shape life itself, the gradual changes within the body, and the quiet question of whether those processes can be guided or even gently altered. As we rest with this idea that our tools are beginning to mirror the quiet logic of nature, something hopeful begins to take shape, because for a long time there have been questions we simply could not answer, not because we lacked curiosity, not because we lacked effort, but because the problems themselves were too vast, too intricate, too filled with possibilities, like trying to understand the shape of a cloud by examining one droplet at a time, or trying to predict the path of every ripple in an ocean by following each wave separately. There are systems in this world where everything influences everything else, where a single change, even a small one, can ripple outward, creating patterns that are almost impossible to track step by step. And for these kinds of systems, traditional methods often reach their limits. But now, something is changing, not suddenly, not dramatically, but steadily, quietly, in the background. Because when we begin to use systems that can explore many possibilities at once, we begin to approach these problems differently, not by forcing them into simpler shapes, but by allowing their complexity to unfold in a way we can begin to follow. One of the most profound areas where this shift is happening is in medicine, inside your body. There are countless processes unfolding every moment. Proteins folding into precise shapes, molecules interacting in delicate sequences, signals travelling, adjusting, responding. And within this complexity, small changes can have large effects. A single, misfolded protein can lead to disease. A tiny mutation can alter how a cell behaves. For decades, scientists have tried to understand these processes, but the number of possible configurations is enormous, far beyond what classical methods can easily explore. Now imagine a system that can move through many of these possibilities at once, not testing each one individually, but sensing patterns, identifying stable configurations, finding pathways through the complexity. This is one of the promises of quantum computing. Not a guarantee, not a finished solution, but a new way of approaching problems that once felt out of reach. And if we can better understand how proteins fold, how molecules interact, we may begin to design treatments as with greater precision, to develop medicines, not through trial and error alone, but through deeper insight into the underlying patterns. Now, this doesn't mean instant cures. It doesn't mean that all diseases will disappear, but it suggests a shift from reacting to illness to understanding it at a more fundamental level. And from understanding comes the possibility of prevention. Now, beyond the body, there are other systems, equally complex, the climate, for example, a vast network of interactions between air, water, land, energy, living systems, each part influencing the others, each change rippling outward. For a long time, we've tried to model these systems, to predict how they evolve, but the sheer number of variables, the countless interactions, make this incredibly challenging. Now imagine approaching this not as a sequence of isolated calculations, but as a landscape of possibilities, a system that can explore multiple scenarios, simultaneously, gently tracing the patterns, identifying trends, revealing connections that were previously hidden. This doesn't make the system simple, but it makes it more understandable, more navigable, and this understanding may help guide decisions, not with perfect certainty, but with greater clarity. Now there is another area where this quiet shift becomes especially meaningful: energy. The processes that power our world, from the smallest devices to entire cities, are based on transformations of matter and energy. Some of these processes, like the fusion reactions that power stars, are incredibly efficient, but also incredibly difficult to reproduce, because they involve complex interactions under precise conditions. Understanding these interactions in full detail has been beyond our reach, but with tools that can explore many possibilities at once, we may begin to approach these systems differently, not forcing them, but learning from them, understanding the patterns that allow them to stabilize, to sustain, to continue, and perhaps, over time, finding ways to bring those patterns into our own technologies. Now, all of this may sound expansive, far-reaching, but there is something very gentle at its core, because each of these advances begins with the same idea: not control, but understanding, not forcing outcomes, but learning how possibilities unfold. And this brings us back, quietly, to the deeper question, because as we begin to understand these complex systems, as we begin to see how patterns emerge, how processes stabilize, we inevitably turn inward to the most intricate system we know, ourselves, because the same principles, the same interplay of possibilities, the same quiet unfolding of patterns exists within the body, within every cell, within every moment of life. And this raises a question, not in a dramatic way, but gently, almost inevitably. If life itself is a system of patterns, if it is shaped by interactions, by processes, by accumulated changes, then what we call aging may not be a fixed fate, but a process, a gradual accumulation of tiny shifts, tiny errors, tiny imbalances. And if that is true, then perhaps it is something we can begin to understand. And if we can understand it, then perhaps, in time, we may learn how to influence it. Not completely, not perfectly, but gently, in small ways, ways that extend, stabilize, support, the patterns that sustain life. And as we continue, we will move into that space, not as a place of certainty, but as a place of quiet exploration, where physics meets biology, where possibility meets time, and where the question of how long something can continue begins to feel just a little less fixed. As we slowly move closer to ourselves, from galaxies, from particles, from the quiet patterns of reality, we arrive at something much more familiar, something you can feel, even now, the steady presence of your body, breathing, resting, working, quietly, without asking for attention. And within that quiet work, something else is happening, something so gradual, so gentle, that we rarely notice it from one moment to the next. But over time, it becomes undeniable. We change, we grow, and eventually, we age. Now, aging often feels like a mystery, something inevitable, something written into life itself. But when we look more closely, through the lens of science, it begins to appear less like a sudden event and more like a process, a slow accumulation of tiny changes, tiny imperfections, tiny shifts that build up over time. You can think of it like a well-used machine, not in a cold or mechanical way, but in a simple, familiar sense. Imagine a car, one that runs smoothly when it's new. The engine is clean, the parts move easily, everything fits just as it should. But as time passes, the engine begins to collect small traces of wear, tiny particles of dust, heat causing slight changes in materials, friction leaving its mark, little by little. None of these changes are dramatic on their own. You wouldn't notice them from one day to the next. But over months, over years, they begin to accumulate, and eventually, the system no longer runs as smoothly as it once did. Now, your body is far more complex than any machine, infinitely more adaptive, infinitely more capable of repair. But in a quiet way, something similar is happening. Every moment, your body is using energy, and whenever energy is used, there is always a small amount of waste, small byproducts, small imperfections, tiny changes in the structures that make up your cells. Your body works constantly to repair these changes, to correct errors, to maintain balance, and for a long time, it does this remarkably well, almost effortlessly. But over time, the balance shifts, not suddenly, not all at once, but gradually. The repairs become a little less perfect. The small imperfections begin to linger, and slowly they begin to accumulate. This is one way to understand aging, not as a single cause, but as the result of many tiny processes unfolding together. Now, one of the most important places where this happens is within something very small, something that carries the instructions for how your body functions. You can think of it as a kind of internal guide, a set of patterns that tell your cells what to do, how to grow, how to repair, how to respond. And over time, even these instructions can be affected, not erased, not completely lost, but slightly altered. Small changes here and there, tiny misreadings, subtle shifts. And while your body has ways to correct these, to detect and repair them, it is not perfect. No system is. And so, over many years, these small changes begin to shape how cells behave. Some cells become less efficient, some stop dividing, some continue dividing, but not in the way they should, and this contributes quietly to the overall process of aging. Now, there is another layer to this. Because your body is not just a collection of cells, it is a network, a system of systems, each part influencing the others, your immune system, your metabolism, your nervous system, all interacting, all adjusting, all responding. And as time passes, these systems also change. The signals become slightly less precise, the responses slightly slower, the balance slightly harder to maintain. Again, not suddenly, not dramatically, but gently, like a rhythm that becomes just a little less steady over time. Now, there is something important to notice here, because when you think of aging this way, it stops being a single, fixed event and becomes something else, a process, a gradual unfolding, a pattern shaped by many small factors. And this opens a quiet possibility. Because if aging is a process, then perhaps it is something we can begin to understand, not completely, not all at once, but step by step, pattern by pattern. Because the more we understand how these small changes occur, how they accumulate, how the body responds, the more we may be able to influence them. Not to stop aging entirely, not to escape it, but perhaps to guide it, to slow certain processes, to support the body's natural repairs, to extend the time during which the system remains balanced. And this is already happening, or in small ways, through medicine, through better understanding of nutrition, through research into how cells repair themselves. Nothing dramatic, nothing sudden, but quiet progress, gradual, like everything else we've explored. Now, as you sit with this idea, there is something calming about it, because it frames aging not as something that suddenly happens to you, but as something that unfolds gently over time. A process your body has been navigating since the very beginning, and even now, as you rest, as your breathing slows, your body continues its quiet work, repairing, adjusting, maintaining balance as best it can, without asking for attention, without needing recognition, just continuing. And this brings us to a gentle question, because if aging is a process, if it is shaped by patterns, by interactions, by accumulated changes, then what happens when we begin to understand those patterns more deeply? What happens when we learn not just to observe them, but to gently influence them, not with force, not with control, but with understanding? And as we move forward, we will explore that possibility, not as a promise, but as a direction, a quiet path, opening slowly into the question of whether time within the body can be so softened. If we continue gently from that thought, aging is not a single moment, but a gradual unfolding, something shaped by countless small changes. Then another quiet possibility begins to appear, not a dramatic one, not something that promises perfection, but something softer. If aging is a process, then perhaps it is a process that can be understood. And if it can be understood, then perhaps, in some small ways, it can be guided, not stopped, not reversed entirely, but gently influenced. Now, to explore this idea, we return to something we touched on before, the internal instructions that guide your body, the patterns that tell your cells how to grow, how to repair, how to respond. You can think of these instructions as a kind of living script, not fixed like words carved into stone, but dynamic, responsive, changing, depending on the environment, the signals, the conditions within the body. Every cell carries this script, and yet, not every part of the script is used at every moment. Some instructions are active, others remain quiet, and what determines this is not just the script itself, but how it is read, how it is expressed. Now, over time, this expression can shift. Some parts of the script become less active, others become more active than they should. The balance slowly changes, and this contributes quietly to the process of aging. But here is where something hopeful begins to emerge. Because if aging involves changes in how this internal script is used, then perhaps we can learn how to influence that process, not rewriting the script entirely, but guiding how it is read. And this is one of the areas where modern research is focused. Understanding how cells maintain balance, how they repair themselves, how they respond to stress, to energy, to their environment. Now, there are certain systems within the body that play a role in maintaining stability. You can think of them as quiet regulators. They help manage energy, they help coordinate repair, they help keep processes running smoothly. And when these systems function well, the body maintains balance more easily, damage is repaired more effectively. The accumulation of small errors slows. Now, as we learn more about these systems, we begin to see patterns, conditions that support balance, conditions that disrupt it, and this opens the door to something subtle but meaningful. Because instead of viewing aging as something completely outside our influence, we begin to see it as something partially responsive, something that can be shaped gently over time. Now, this is not about dramatic interventions, not about sudden transformations, but about understanding the conditions that allow the body to function well, to repair itself, to maintain stability. And this includes many things, some simple, some complex, how energy is used, how cells respond to stress, how systems communicate, even how the body rests and recovers. All of these contribute to the overall pattern. And as research continues, new possibilities emerge, ways of supporting the body's natural repair processes, ways of reducing the accumulation of damage, ways of extending the period during which the system remains balanced. Now, there is also a more speculative layer to this, something that connects back to the deeper physics we explored earlier, because at the smaller scales, within molecules, within the interactions that sustain life, there are processes that unfold in subtle ways, delicate interactions guided by the same underlying rules that shape the quantum world. And while this field is still developing, there's a growing sense that life itself may depend in part on these subtle processes, not in a dramatic or mysterious way, but in a quiet, foundational sense. And as we begin to understand these processes more clearly, we may find new ways to support them, to maintain the conditions under which they function best. Again, not as a way of escaping aging, but as a way of understanding it more deeply. Now, as you sit with this idea, it's important to keep it grounded, because the goal is not to imagine a future where time stops, or where life becomes endless, but to recognize something simpler, that the body is not static, it is not fixed, it is a dynamic system, constantly adjusting, constantly responding, constantly maintaining balance. And within that dynamic system, there is room for influence, for support, for gentle guidance. Now, this brings us to a deeper question, because even if we could slow these processes, even if we could extend the time during which the body remains stable, there is something else we must consider. What does it mean to continue? What defines the end of a life? Is it the moment the body stops? Is it the moment the patterns dissolve? Or is it something more subtle, something connected to the deeper structure of reality itself? Because, earlier, we explored the idea that reality is not fixed, that it includes possibilities, that it may branch, unfold in multiple ways. And if that is true, then the idea of a single definitive ending becomes less clear, not necessarily gone, but softened. And as we move forward, we will begin to explore that question, not as a statement, not as a conclusion, but as a quiet reflection on what it means for something to continue, and whether the boundaries we draw between existence and non-existence are as sharp as they seem. As we rest gently in that question of whether life can be extended, whether the processes within the body can be understood, perhaps even guided, another question begins to rise, a quieter one that doesn't depend only on biology or time or the body at all. Because even if we could slow aging, even if we could extend life, there is something deeper that remains. What does it mean to end? Not in a dramatic sense, not as a sudden disappearance, but in the simplest possible way. When something is no longer here, where has it gone? Now, for most of our lives, this feels like a clear answer. Things begin, things continue, and eventually they stop, align, with a beginning and an end. But earlier, we explored something that gently challenges that idea, the possibility that reality is not a single path, but a landscape of possibilities, that at every moment, multiple outcomes may exist, quietly, and that what we experience is one unfolding among many. Now, it's important to stay grounded here. This is not something we can observe directly. It is an interpretation, a way of making sense of the strange behaviour of the quantum world, but it is a consistent one, a careful one, explored by physicists like Hugh Everett, and within this view, something subtle happens. Because if every possible outcome unfolds in its own way, then reality is not a single line, but something more like a branching structure. At each moment, new paths quietly emerging. Most of these paths are not experienced by us. We follow one, we remember one, we live within one, but the idea suggests that others may exist as well, not as places we can visit, not as hidden worlds just beyond reach, but as separate continuations of possibility. Now let's bring this back, gently, to something familiar. Imagine standing at a crossroads. You choose one direction, you walk forward, your life continues along that path, but there were other paths, other directions you did not take. In everyday life, those paths simply remain unrealized. They fade as possibilities that never became real. But in this interpretation of reality, those possibilities do not vanish. They unfold in their own way, quietly, separately. And this leads to a question that feels both strange and deeply personal. If reality branches, if there are many possible continuations, then what does it mean for you to end? Now, this is not a question with a simple answer, and it's not something we can test or observe directly, but we can explore it gently. Because when we think of ourselves, we often imagine a continuous identity, a single thread of experience moving through time, but that thread is shaped by countless small events, choices, interactions, processes within the brain, patterns, unfolding moment by moment. And if those patterns are part of a larger landscape of possibilities, then identity itself may not be as singular as it feels, not broken, not fragmented, but part of something wider. Now, again, it's important to remain calm with this idea. This does not mean that there are other versions of you, living lives you can access. It does not mean that your experience is duplicated in a way that affects you directly. Your experience remains your own, your path remains continuous, but it suggests that the structure of reality may allow for multiple unfoldings, even if we only perceive one. And this brings us back to the idea of endings, because if reality includes multiple continuations, then the concept of a single, absolute end becomes less clear, not erased, not denied, but softened, like the edge of a shadow that fades gradually, rather than stopping sharply. Now, there is another layer to this, because beyond identity, beyond experience, there is something more fundamental: information, the patterns that define a system, the arrangement that gives something its structure. In physics, there is a growing understanding that information is not easily lost, that even when systems change, transform, evolve, the underlying information may still be preserved in some form, not in a way we can easily access, not in a way that preserves experience or awareness, but in a deeper structural sense. And this connects quietly to everything we've explored. Because if reality is built from patterns, from relationships, from possibilities, then what we call existence may not be as simple as present or absent. It may be a pattern that appears, transforms, and integrates into a larger whole. Now, this is not a claim, not a conclusion, just a way of looking that emerges from the ideas we've explored, and as you sit with it, there's no need to resolve it, no need to decide what it means. It's enough to let the question exist, to notice how the idea of a sharp boundary between being and not being begins to soften, and in that softness there is a kind of calm, because it shifts the focus away from endings and toward continuity, not necessarily personal continuity, not in the way we usually imagine, but continuity of patterns, of processes, of the underlying structure that gives rise to everything. And as we move forward, we will shift again from these quiet reflections back toward the future, toward what happens when intelligence itself continues to evolve, when systems begin to learn, adapt, and perhaps understand in ways that extend beyond us, not as a threat, not as something sudden, but as a gradual unfolding of the same patterns we've been following all along. As we gently step away from that question of continuity, of identity, of what it might mean for something to continue in ways we don't fully perceive, we arrive at another unfolding, not of the universe itself, but of something we have created, something that, in its own quiet way, is beginning to evolve. For most of history, intelligence has been something we associate with living beings, with minds, with awareness, with the ability to perceive, to learn, to adapt. But over the past few decades, something subtle has been happening. We have begun to build systems that can learn, not in the same way we do, not with awareness, not with feeling, but through patterns, through exposure, through repetition. At first, these systems were simple. They could follow instructions, perform calculations, process information, nothing more. But slowly, gradually, they began to change. Instead of following fixed rules, they began to adjust those rules, to recognize patterns in data, to improve over time. You can imagine this progression in a very gentle way, like the development of a simple organism. At first, something that reacts only in basic ways, then something that begins to recognize patterns, then something that adapts, then something that responds more flexibly to new situations, not suddenly, not dramatically, but gradually, step by step. Now, it's important to remain calm with this idea, because these systems, what we often call artificial intelligence, are not conscious. They do not experience the world. They do not feel. They do not have awareness. They are systems designed to process information in increasingly complex ways. But what is interesting is not what they are right now. It is the direction they are moving. Because as these systems become more capable, they begin to handle tasks that once required human intelligence, understanding language, recognizing images, identifying patterns in complex data, making predictions, and they do this, not through understanding in the human sense, but through structure, through patterns, learned over time. Now, if you imagine this progression continuing, not rushing, not accelerating dramatically, but unfolding steadily, a question begins to form. What happens when systems become more capable than we are in certain areas of thinking? Not everywhere, not all at once, but in specific domains. This is already happening in small ways. Systems that can analyze vast amounts of information more quickly than any human could. Systems that can detect patterns, too subtle, too complex, to notice otherwise. And as this continues, the boundary between human capability and machine capability begins to shift, not disappear, but move. And this does not need to be seen as something threatening, because throughout history, tools have extended our abilities. A telescope extends vision, a calculator extends arithmetic, a computer extends memory and processing. In this sense, artificial intelligence can be seen as another extension, the way of interacting with complexity more effectively. Now, there is another layer to this, because as systems become more capable, they also become more autonomous, not in the sense of independent awareness, but in the sense of operating with less direct human guidance, making decisions based on patterns, adjusting based on feedback, learning from experience. And this introduces something new, and not a break from what we've seen before, but a continuation, a system that can evolve its behavior over time. Now again, it is important to stay grounded. This does not mean that machines are becoming conscious beings. There is no clear evidence of that. But it does mean that systems are becoming more sophisticated, more capable, more integrated into the world around us. And as that happens, we begin to rely on them more, not entirely, not exclusively, but increasingly, to assist, to guide, to analyze. Now, if you let that idea settle, gently, it connects back, in a quiet way, to everything we've explored, because intelligence, like everything else, can be seen as a pattern, a process, something that emerges from interactions, from structure, from underlying rules. And if that is true, then it is not surprising that systems built from those same principles can begin to reflect aspects of it, not identical, not the same, but related. Now this leads to a deeper question, not about whether machines will replace us, but about how intelligence itself might evolve. Because for most of history, intelligence has been biological, rooted in the brain, in the body, in living systems. But now, we are beginning to see the possibility of intelligence that is not tied to biology, that exists in systems we have created. And this does not replace human intelligence. It expands the landscape. It adds another layer, another form, another expression. Now, what happens next is not something we can predict with certainty. It will unfold gradually, through small changes, through adjustments, through new questions, emerging over time. But one thing seems clear. We are moving into a world where intelligence is not singular, not confined to one form, but distributed across systems, across tools, across different kinds of processes. And as we move into that world, we are faced with a quiet choice, not a dramatic one, not a single decision, but an ongoing process. How we integrate these systems, how we use them, how we understand their role, not as something separate, but as part of the same unfolding we've been exploring. And as we continue, we'll take one more step, not into machines alone, but into something even more personal. Because if intelligence can extend beyond the body, then what happens when the boundary between the two begins to soften? As we continue from that gentle idea that intelligence may not remain confined to the human mind, that it may extend slowly into systems we create, another possibility begins to emerge, not about machines alone, but about us. Because for a long time, the boundary between human and technology has been very clear. We use tools, we interact with them, but they remain outside of us, separate, distinct. A device in your hand, a screen in front of you, something you can turn on or off. But what happens when that boundary begins to soften? Not suddenly, not dramatically, but gradually, over time. Because even now, in very early forms, we're already seeing the first steps, small devices that interact with the body, systems that can monitor signals, detect patterns, respond to changes. Nothing extraordinary, nothing that changes who we are, but small extensions, gentle additions. Now imagine this continuing, slowly, carefully, over many years, technology becoming more integrated, not as something external, but as something that works alongside the body, supporting it, enhancing certain functions, helping where natural processes struggle. This is what is often described as human augmentation, and while the term may sound complex, the idea is simple, not replacing the human, but extending it. Now, there are many ways this could unfold, and it's helpful to imagine it not as a single path, but as a spectrum. At one end, very light integration, tools that assist, without changing the core of what you are. Devices that help with memory, systems that support decision-making, quiet enhancements that remain clearly separate, moving further along, more direct interaction, interfaces that connect more closely with the body, allowing signals to pass more seamlessly between biological systems and technology, helping restore lost functions or enhance existing ones. And at the far end of the spectrum, something more profound, a deeper integration, where the boundary between biological and technological becomes less defined, not disappearing entirely, but blending. Now, it's important to approach this idea with calm, because this is not something that happens all at once, not something inevitable in a dramatic sense, but a gradual unfolding, small steps, careful developments, each one shaped by choices, by ethics, by understanding. And not everyone will move along this spectrum in the same way. Some may choose minimal interaction, others may explore deeper integration, and many will remain somewhere in between. This creates not a single future, but a range of possibilities, different paths, unfolding at the same time. Now, this introduces something new into the human story: variation, not just in culture or environment, but in the way people interact with technology itself, and this may lead to differences in capability, in experience, in perspective, not necessarily in a dramatic or divisive way, but in subtle ways, gradual shifts, now, again. This is not something to fear, it is simply something to understand, because throughout history, humans have adapted, we have changed, slowly, in response to new conditions, new tools, new environments, and this is another step in that long process. Now, if you sit with this idea for a moment, it connects back to everything we've explored. Because if reality is built from patterns, if identity is a process, not a fixed object, if intelligence can emerge from different systems, then the boundary between what is natural and what is created becomes less rigid, not erased, but softened. Now, this raises a quiet question, not about whether this will happen, but about how we relate to it, because at its core, this is not just a technological shift, it is a shift in perspective, in how we understand ourselves. Are we defined by our biology alone, or by the patterns, the processes, the continuity of experience? If those patterns can be supported, extended, even partially transferred, what remains the same and what changes? Now, there's no need to answer this, not tonight, not quickly. These are questions that unfold slowly, over time, through experience, through reflection, through the quiet evolution of understanding. But what matters is that we approach them with care, with thoughtfulness, with an awareness that every step is part of a larger unfolding. Now, as we move toward the final part of our journey, we begin to step back from the details, from the systems, from the possibilities, and return to something broader. Because after exploring reality, life, intelligence, the future, there is still a quiet edge, a place where understanding gently fades into wonder, where questions remain, not as problems to solve, but as spaces to rest. And as we arrive there, we will not try to resolve everything. We will not try to draw firm conclusions. Instead, we will simply observe, gently, calmly, and allow the ideas to settle into something softer. And so, we arrive here, not at a sharp conclusion, not at a final answer, but at a quiet edge, a place where everything we've explored gently comes to rest. We began with something simple, a feeling that the time we are living in is changing, that beneath the surface of everyday life, something deeper is unfolding, and slowly, step by step, we followed that thread. We looked at reality and found that it is not as solid as it seems, that at its smallest scales it is made of possibilities, soft patterns, waiting to become real. We explored the idea that the universe itself may not be alone, that there may be other paths, other unfoldings, beyond what we can see, not as distant places, but as part of a deeper structure. We listened to the idea that everything might be built from vibration, from quiet patterns, like notes in a symphony, some heard, some just beyond perception. We discovered that most of the universe is hidden, not gone, not absent, but simply unseen, a vast structure supporting everything we know. And then we turned inward, to life itself, to the body, quietly working, to the process of aging, not as a sudden event, but as a gradual unfolding, a pattern shaped by time. And we asked, gently, if it is a process, could it be understood? Could it be influenced, not controlled, not stopped, but guided? And from there, the question deepened. If reality allows for multiple possibilities, if identity is a pattern, not a fixed object, then what does it mean to end? Is there a single boundary where everything stops, or something softer, something that continues in ways we do not fully perceive? And then we looked ahead, to the systems we are building, to intelligence, extending beyond the human mind, to the possibility of technology, blending, slowly, with biology, not replacing, but supporting, not transforming us instantly, but gently reshaping what it means to be human. And now, here we are, at the edge of all of that, where knowledge begins to soften, where certainty gives way to quiet curiosity, because despite everything we have learned, there is still so much we do not know. Science is powerful. It allows us to test ideas, to observe patterns, to build understanding, step by step. But it also has limits. There are questions it cannot fully answer, not because they are unimportant, but because they exist at the edge of what can be measured, and beyond that edge, there are other ways of understanding, ways that are not based on measurement, but on meaning, on reflection, on experience. Throughout history, people have explored these questions in different ways, some through science, some through philosophy, some through belief. And while these approaches may seem different, they often circle around the same quiet questions. What is reality? What does it mean to exist? What happens when something ends? Now, we don't need to choose one answer. We don't need to resolve these questions tonight, because there is something gentle in not knowing, in allowing space for possibility, in recognizing that understanding can be both precise and open. And when you sit with that, there is a kind of calm, because it reminds you that you are part of this unfolding, not separate from it, not observing from a distance, but within it. Your thoughts, your experiences, your awareness in this moment, all part of the same pattern, the same processes, the same quiet structure that we have been exploring And whatever the ultimate nature of reality may be, whether it is a single unfolding or many, whether existence has a clear boundary or a softer continuity, one thing remains true. You are here, now, part of this moment, part of this universe, part of this quiet, ongoing story. And perhaps that is enough, not as an answer, but as a place to rest, a place where curiosity does not need to resolve, where questions do not need to close, where understanding can remain, open and gentle. And so, as we begin to drift toward the end of tonight's journey, there is nothing left to figure out, nothing left to hold on to, just the quiet sense that the universe is vast, that it is layered, that it is still unfolding, and that you, in your own way, are part of that unfolding. And so, we've reached the end of tonight's exploration. Whether your eyes are still open, or you're already floating somewhere between waking and dreaming, thank you for being part of this little journey. If you'd like to join me again for more gentle wanderings, you're always welcome to subscribe or share this with someone who could use a peaceful pause. Time has a way of slipping through our fingers, but here, in this quiet moment, it's just you and the soft hush of rest. Sleep peacefully, wherever and whenever you may be.